All right, guys, so we have 4 different ways of calculating delta H. We already talked about the first 2, delta H of combustion values and delta H of formation values. Those 2 are not as heavily stressed on your assignments and or the test, so we're going to focus on the next 2. So the third one is called average bond enthalpies. You're going to use average bond enthalpy values from the data booklet to calculate this. So you need to have your data booklet handy. So in this one, it's a little different because you are doing the sum of the delta H's of the bonds that are broken minus the sum of the delta H values of the bonds that are formed. And so since reactants are the ones that break their bonds, right? Because they have to break their bonds before the atoms move around, rearrange, and then form new products. The broken bonds belong to the reactants, and the formed bonds belong to the products. So this sum of delta H of the broken bonds minus the sum of the delta H's of the formed bonds is the same as the sum of the delta H of the reactants minus the sum of the delta H of the products. So what does that mean? That means that it is different than the previous 2. The 2 we did yesterday were products minus reactants. This one is reactants minus products. So something else that makes this a little bit more complicated is that you're going to have to be very aware of the structures of the compounds. And so you're going to have to practice your structures again. For example, you have to know if there's a single bond, a double bond, a triple bond. Like in topic 10, remember when we were doing alkanes, alkenes, and alkynes, you have to know those different types of bonds. You have to know valence electrons. You have to know if a substance has 2 bonds. For example, oxygen always has to have 2 bonds. So is it bonded to 2 different things, or does it have a double bond? Nitrogen is always going to have 3 bonds. So is it bonded to 3 different things, or does it have a triple bond or a double bond and a single bond, etc.? So you are going to have to be very aware of the structures. That is going to be very important, as you'll see in the example. Okay, here's our example then. Determine the delta H value of the reaction using average bond enthalpies. So I'll show you where to find that in the data booklet. And here is the reaction that we're going to be using. So N2 plus 3H2, and it forms 2 moles of NH3. All right, so really quick, let's look at our data booklet. So again, you guys have access to that. It's page 11, bond enthalpies and average bond enthalpies. So check this out. You are going to use this table to see, okay, is a carbon bonded to a carbon? If so, the value would be 346. Is a fluorine bonded to a hydrogen? You'd have to come down here. The value would be 567. Okay? These are for single bonds. Now, they have these multiple bonds. So if it's a C double bond C, you got 614. C triple bond C, you got 839, etc. C triple bond N, 890. O double bond O, 498. You get the idea. So page 11 is where you get these values from your data booklet. Okay? So keep that handy as we work out our example. Okay, so here we go. So our reaction again, N2 plus 3H2 forms 2 moles of ammonia. Here's how you do that. You have to know the structures. So N2, you have to know that N2 is N triple bond N. 3 moles of H2. You have to know that 3 times 3 of those H to H bonds. So H2 is just H single bond H, right? on the product side, there's 2 moles of NH3. Well, what does NH3 look like? You should know that this is what NH3 looks like based on valence electrons. It's N bonded to 1, 2, 3 hydrogens. Therefore, it is 2 from the coefficient, 3 because of the 3 single bonds from N to H. See that? Okay, now I go to my data booklet. I want you guys to go see that for N triple bond N, the value is 945. For H single bond H, the value is 436. For N single bond H, the value is 391. So now you're just going to do the math. 945 plus this right here gives you 1308. On the product side, this is 6 times 391, which is going to give you 2346. Finally, this is reactants minus products, right? Because remember, it's the sum of the broken bonds minus the sum of the formed bonds. So what do you get? 2253 minus 2346, which equals negative 93 kilojoules per mole. That's the delta H value of this reaction using average bond enthalpies. And I've summarized that there on the bottom.